Have you ever wondered what secrets lie beyond our solar system? Bill Nye recently revealed something that, honestly, sent shockwaves through the scientific community. Voyager 1 has detected 300 massive objects floating in the depths of interstellar space. After 45 years of exploration, this aging spacecraft continues to make discoveries that challenge everything we thought we knew about the cosmos. These aren't just random space debris. They're mysterious structures that could hold the key to understanding whether we're truly alone in the universe. Today, we're diving deep into Voyager's most mind-bending revelations. The genesis of Voyager's epic journey. Back in 1977, NASA launched what would become humanity's most ambitious space exploration mission. Voyager 1 and Voyager 2 were originally designed for a simple 5-year mission to study Jupiter and Saturn. But these remarkable spacecraft had other plans. The timing was perfect, a rare planetary alignment that occurs only once every 175 years, allowed the probes to use gravitational slingshots to reach the outer planets faster than ever before. What started as a modest exploration of gas giants evolved into the grand tour of our solar system. Voyager 2 became the first and only spacecraft to visit Uranus and Neptune, capturing images that, well, totally revolutionized our understanding of these distant worlds. The mission's success exceeded all expectations, with both spacecraft continuing to function decades beyond their planned lifespan. The secret to their longevity lies in their nuclear-powered systems and robust 1970s engineering. While their computers have less processing power than a modern calculator, their reliability has proven unmatched. Today, nearly half a century later, these cosmic pioneers continue transmitting data from the edge of known space, redefining what's possible in space exploration. Breaking the ultimate barrier. August 25, 2012 marked a historic moment in human exploration. Voyager 1 became the first human-made object to enter interstellar space. At 11 billion miles from the Sun, it crossed the heliopause, the boundary where our Sun's influence ends and the vast wilderness between stars begins. 6 years later, Voyager 2 joined its twin in this cosmic frontier, making them humanity's only ambassadors to interstellar space. The journey to this milestone wasn't easy. As the spacecraft approached the heliopause, they encountered a turbulent region where the solar wind collides with the interstellar medium. This cosmic battleground creates a protective bubble around our solar system, shielding us from the galaxy's harsh radiation. Voyager's instruments revealed that cosmic rays beyond this shield are 3 times more intense than within our solar system's protective embrace. The transition into interstellar space wasn't gradual, it was like stepping from a bustling city into a silent wilderness. The spacecraft's magnetometers detected the sudden change in magnetic field direction, while particle detectors registered the dramatic shift in cosmic ray intensity. This moment represented humanity's first direct contact with the space between stars, opening an entirely new chapter in our cosmic exploration. The mysterious humming of deep space. One of Voyager 1's most intriguing discoveries came in the form of sound, a low, persistent humming detected in the vast emptiness of interstellar space. This cosmic symphony isn't actually sound as we know it, but rather vibrations in the sparse gas that exists between stars. The discovery challenged our understanding of interstellar space as a perfect vacuum, revealing instead a dynamic environment filled with subtle activity. The humming represents the vibrations of electrons in the interstellar plasma, creating what scientists call plasma waves. These waves provide crucial information about the density and temperature of the interstellar medium, helping us understand the conditions that exist in the 99.9% of space that lies between star systems. The consistency of this humming suggests that interstellar space has a more uniform structure than previously thought. NASA's Nicola Fox emphasized the significance of this discovery, noting that no other spacecraft could have made such observations. The detection required Voyager's unique position beyond the heliopause and its sensitive instruments, which continue to function despite the extreme cold and radiation of deep space. This cosmic humming serves as a constant reminder that even in the apparent emptiness of space, there's always something happening. We just need the right tools to detect it. Defying death in the cosmic deep. Voyager's survival story honestly reads like science fiction. These spacecraft were designed to operate for just 5 years, powered by plutonium-238 that, gradually decays over time. As the radioactive fuel ages, it produces less heat, forcing NASA to make increasingly difficult decisions about which systems to shut down. Heaters that were meant to keep instruments warm in the -270°F environment of space, well, those were turned off years ago. Yet somehow, all 5 scientific instruments on both spacecraft are still functioning perfectly. This really defies all engineering expectations and, frankly, puzzles NASA experts who expected the instruments to freeze and fail long ago. The spacecraft's resilience truly demonstrates the exceptional quality of 1970s engineering and the conservative design philosophy that built redundancy into every system. The power situation gets more critical each year, with both spacecraft losing about 4 watts of power annually. NASA engineers are constantly juggling which systems to keep online, always prioritizing the most scientifically valuable instruments. Despite all these challenges, the spacecraft continued to transmit data across the 15 billion-mile void, with signals taking over 22 hours to reach Earth. This remarkable endurance has extended humanity's reach into the cosmos far beyond anyone's wildest dreams. The shape-shifting boundary of our solar system. The heliopause, which is our solar system's boundary, isn't the static barrier scientists once believed it to be. Instead, it's this dynamic, ever-changing frontier that actually moves and shifts like a living organism. Data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite reveal that this cosmic boundary creates unexpected angles and irregularities, really challenging our understanding of how solar systems interact with interstellar space. This discovery helps explain why Voyager 1 and Voyager 2 entered interstellar space 6 years apart, even though they were launched just weeks apart. The heliopause had shifted significantly between their crossings, demonstrating the dynamic nature of this cosmic frontier. Scientists observed the boundary moving at speeds that just contradicted existing models, suggesting that the interaction between solar wind and the interstellar medium is way more complex than previously thought. The implications are, honestly, pretty profound. If our solar system's boundary is constantly shifting, it affects how cosmic rays penetrate our protective bubble and influences the space environment around all the planets. Recent studies published in Nature Astronomy describe these findings as eye-opening, acknowledging that they challenge some fundamental assumptions about heliospheric physics. Future missions, including NASA's upcoming Interstellar Mapping and Acceleration Probe, will help scientists better understand this mysterious boundary. Electronic aphasia in deep space. In May 2023, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude control system started sending garbled, incoherent data back to Earth. Like a person struggling to speak clearly, Voyager 1 seemed to lose its ability to communicate effectively, sending random patterns instead of meaningful telemetry about its health and status. The mystery only deepened when engineers realized that, despite the communication problems, Voyager 1 was actually functioning perfectly. Its radio signal remained strong and stable, which meant the high-gain antenna was still properly pointed toward Earth. The spacecraft's scientific instruments continued operating normally, completely unaware of the communication anomaly affecting their host vehicle. NASA's investigation revealed that the attitude control system had switched to a backup computer that had been dormant for years. A simple command to switch back to the primary computer resolved the issue, but the root cause still remained puzzling. Engineers suspect that cosmic radiation or maybe an errant command from another onboard system triggered the switch, highlighting the challenges of operating decades-old technology in the harsh environment of interstellar space. This incident demonstrated both Voyager's vulnerability and its remarkable resilience, proving that even after 45 years these spacecraft can overcome unexpected challenges. Cosmic IT support across 15 billion miles. Managing Voyager's computer systems presents some pretty unique challenges, honestly, challenges that make Earthbound IT support look, well, simple by comparison. These spacecraft operate with technology from the 1970s, including computers that have just 70 kilobytes of memory. That's actually less than a single smartphone photo. Yet NASA engineers regularly send software updates across the 15 billion mile void, and, that process takes over 22 hours each way at the speed of light. The programming challenges here are immense. Engineers have to write code in assembly language, the most basic form of computer programming, because get this, the spacecraft don't have operating systems or any advanced programming tools. Every instruction has to be crafted to work directly with the hardware. which really requires intimate knowledge of systems that were designed nearly half a century ago. And the code, well, it has to be absolutely perfect. There's just no opportunity for quick fixes when the nearest technician is 15 billion miles away. These software updates aren't just, routine maintenance, they're actually lifesavers. Over the years, updates have fixed failing hardware components, optimized power consumption, and even activated backup systems when primary components failed. One critical update actually saved Voyager 1 from potential disaster by activating a fail-safe mechanism when a hardware component stopped working. This kind of cosmic IT support honestly represents one of the most challenging technical achievements in human history. And it's what's kept humanity's most distant explorers operational against all odds, revolutionizing our understanding of planetary worlds. Voyager's planetary discoveries, fundamentally changed our understanding of the solar system. Jupiter revealed itself as a world of extremes, with hundreds of massive storms, glowing auroras at its poles, and a complex ring system that's even more intricate than Saturn's. The Great Red Spot, which is a hurricane larger than Earth, had been raging for centuries, really showing us the incredible power of atmospheric dynamics on gas giant planets. Saturn's rings, once thought to be simple bands of ice and rock, turned out to be incredibly complex structures with thousands of individual ringlets and honestly, these braided patterns that just defied explanation. The discovery of spokes in Saturn's rings, those mysterious dark features that rotate with the planet, revealed that ring systems are way more dynamic than anyone ever imagined. But maybe the most shocking thing was the discovery of active volcanoes beyond Earth. Io, Jupiter's innermost large moon, displayed sulfur volcanoes erupting hundreds of miles into space, while Neptune's moon Triton showed nitrogen geysers erupting at temperatures near absolute zero. These discoveries proved that geological activity wasn't just limited to rocky planets, opening up new possibilities for understanding planetary formation and evolution. And most intriguingly, Voyager revealed that Europa and Enceladus likely harbor vast oceans beneath their icy surfaces, making them prime candidates for harboring extraterrestrial life. The Golden Record and humanity's cosmic message. Each Voyager spacecraft carries humanity's most ambitious message to the cosmos, the Golden Record. This 12-inch gold-plated copper disc contains sounds, images, and music representing Earth's diversity, including greetings in 55 languages and natural sounds from wind, rain, and animal calls. The record serves as a time capsule of human civilization, designed to survive for billions of years in the vacuum of space. Carl Sagan, who really spearheaded the Golden Record project, envisioned it as humanity's introduction to any extraterrestrial intelligence that might encounter the spacecraft. The record includes mathematical and scientific information, human anatomy diagrams, and cultural achievements ranging from Bach to Chuck Berry. It represents our species' optimistic belief that intelligence and curiosity are universal traits that could bridge the gap between civilizations. The Golden Record transforms Voyager from mere scientific instruments into cultural ambassadors. Long after their scientific missions end, these spacecraft will continue carrying humanity's message through the galaxy. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star, Gliese 445, potentially becoming the first human artifact to enter another star system. This cosmic message represents humanity's profound desire to connect with something greater than ourselves, embodying our species' eternal quest to understand our place in the universe. Legacy of discovery and future exploration. Voyager's legacy extends far beyond its original mission, inspiring decades of subsequent space exploration. The spacecraft's discoveries at Jupiter led directly to the Galileo and Juno missions, while Saturn observations inspired the Cassini-Huygens mission that spent 13 years studying the ringed planet. Voyager 2's brief encounters with Uranus and Neptune remain our only close-up studies of these ice giants, though, future missions are planned for the 2040s. Today, both Voyagers continue transmitting data from interstellar space, with NASA expecting to maintain contact until the late 2020s. The spacecraft will eventually fall silent as their power sources decay, but their journey will continue for millions of years. In about 300 years they'll enter the Oort cloud, and after 30,000 years, they'll leave our solar system entirely to orbit the galactic center. Current missions like Europa Clipper and the planned Dragonfly mission to Titan build directly on Voyager's discoveries, targeting the most promising locations for finding extraterrestrial life. The spacecraft's detection of subsurface oceans on Europa and Enceladus has absolutely revolutionized astrobiology, making these moons priority targets for future exploration. Voyager's story reminds us that the greatest discoveries often come from pushing beyond our intended limits, proving that human curiosity and engineering excellence can overcome any obstacle the universe presents. From detecting mysterious objects in interstellar space to revealing the hidden oceans of distant moons, Voyager 1 has fundamentally changed our understanding of the cosmos. Bill Nye's revelation about those 300 massive objects reminds us that even after 45 years, these remarkable spacecraft continue making discoveries that challenge our assumptions about the universe. As Voyager drifts ever deeper into the cosmic unknown, it carries with it humanity's greatest hopes and dreams. Thanks for watching Stellar Tech, and don't forget to subscribe for more incredible journeys into the mysteries of space and science.